Welcome in Dark Core. NASA had continued plans for moon exploration and wanted to send astronauts to Mars by the 1980s. If these plans had happened on schedule, astronauts would have set foot on the red planet around the time Apple released its first Macintosh computers. But now we have iPhones, and NASA still hasn't sent humans to Mars or even resumed missions to the moon. What has kept NASA from putting humans back on the moon after all this time, and what unknown cosmic dangers do astronauts really face? INTRO, everyone knows that the Apollo missions to the moon weren't always without some hazards or incidents. When the astronauts on the Apollo spacecraft circled the night side of the moon, they saw a bright crescent of light on the moon's horizon. At the time, no one could have imagined that it would become a serious obstacle to the exploration of the moon. Scientists believe the eerie glow is lunar dust captured by strong electric fields, and generated at the boundary of the day and night sides of the moon. The sunlight scatters through the microscopic particles and creates a glow. It sounds pretty, but the abrasive, sticky, and electrically charged dust permeated everything, quickly tearing spacesuits and disabling equipment. On Mars, dust has also caused a lot of damage to rovers. But these aren't the only problems. So why hasn't NASA sent anyone to the moon since the Apollo missions, and what about the future plans for Mars? One giant obstacle for getting humans to the moon and beyond is budget. By 1974, the goal of winning the space race against the Soviet Union had been achieved. Government funding for NASA was cut from 4% to less than 1% of the federal budget. NASA's focus shifted to low Earth exploration and the Space Shuttle program. NASA's annual budget has since increased by 3% to about $24 billion for 2022. And it's very expensive to send astronauts to the moon, and NASA will have to save money where it can. A reliable ship and a launch vehicle are top priority. So why not use the previously proven Saturn V rocket? NASA launched a total of 13 Saturn V rockets that took 24 astronauts to the moon. Even today, 60 years later, the rocket's performance is astounding. On the launch pad, it measured 111 meters, 363 feet, tall. That's around 18 meters, 60 feet, taller than the Statue of Liberty. The first stage engines provide 7.6 million pounds, 34.5 million newtons, of thrust. That's the power equivalent of 85 Hoover dams. The problem is that bringing Saturn V back to life is almost impossible. When the Apollo program ended, the manufacturing plants were repurposed or closed. Plus, more than half a century has passed and the spacecraft would need to be upgraded. Even the development of a new vehicle takes 3 years. To build an airplane, you would need 6 years. Just imagine how much time would have to be spent on a rocket with over 3 million parts. For the first time in a generation, NASA is developing a new launch vehicle called the Space Launch System. Together with the Orion spacecraft, it will be used to fly to the moon and possibly to Mars. Orion is an upgraded version of the Apollo spacecraft. It consists of a capsule for crew members and a service module. Orion is approximately 8 meters, 26 feet, long and has a diameter of about 5 meters, 16.5 feet. To test the spacecraft, scientists plan to first send it to the moon with no astronauts on board. It will travel 64,300 kilometers, 40,000 miles, past the moon in about 3 weeks. This is farther than any manned spaceship has traveled before. The crew module of the spaceship is equipped with life support, power systems, and thermal protection, allowing astronauts to spend 21 days there during space missions. The test mission, Artemis I, is planned to begin in the early 2020s. A crewed Artemis II mission will last about 10 days and take astronauts as far as 7,400 kilometers, 4,600 miles, past the far side of the moon. And if everything goes according to plan, the next Artemis III mission will land the first woman and next man on the surface of our satellite. Mike Sarafin, Artemis mission manager, says the team aims to accomplish the goal by 2024. To keep astronauts safe, scientists have come up with the Launch Abort System, LAS, which consists of 3 propellant rocket motors. If something goes wrong during launch, LAS will immediately activate and pull astronauts away from the falling rocket with escape rockets. When Orion returns back to Earth and enters the atmosphere, it will reach a speed of 40,200 kilometers, 25,000 miles, per hour and become extremely hot. To ensure safe re-entry from deep space return velocities, the spacecraft's crew module is protected with a large heat shield 5 meters, 16.5 feet, in diameter and capable of withstanding roughly 50% the sun's temperature. But the construction of the rocket is extremely expensive, and its development is behind schedule. Meanwhile, the Starship Human Landing System, HLS, is being built for astronauts to safely land on the Moon. Partnering with SpaceX, NASA developed the first commercial human lander. The Space Launch System rocket will launch aboard Orion and take 4 astronauts to lunar orbit. 2 of the 4 crew members will then be transferred to the HLS to complete the final stage of their journey and land on the lunar surface. A series of missions on and around the Earth's satellite will prepare us for the following huge step for humanity, a manned mission to the Red Planet. But taking the first settlers to the Moon or Mars is only the beginning. After landing, astronauts will need suitable living conditions. The most important things are food, water, energy, and breathable air. Astronauts aboard the International Space Station, ISS, are already experimenting with growing vegetables using soil pads. Another technology involves hydroponics, where crops grow in water instead of soil. The plan is to use solar energy, but it's not an easy task. Experts believe a space station will have to be built on the north or south pole of the Moon, and that rotating solar panels will be raised above the surface. This way, they won't be blocked by Earth, constantly collecting sunlight. To ensure protection against dust, NASA has already developed spacesuits coated with wax crystals that would have a slippery lotus leaf effect, which refers to the phenomenon of liquid droplets gliding past a surface in the presence of nanostructures. There are also spacesuits with a repelling electrostatic device and ultrasonic cleaning. All this technology is incredible, but things are much more complicated with the human body, as it cannot just be upgraded. A trip to Mars or a long stay on the Moon can do terrible things to the human body. In a weightless environment, bone and muscle mass starts to decrease, the heart becomes weakened, and blood vessels deform. Examinations of astronauts who spent more than half a year on the ISS showed that the brain also suffers. The frontal and parietal lobes will be affected the most. These parts of the brain control body movements. So, without proper planning, the first people on Mars won't even be able to set foot on the planet. To keep astronauts healthy, NASA is implementing a research program to prepare people for long-term space flights. Loss of muscle mass and a weakened heart can be partially compensated by daily exercise. But astronauts on the ISS exercise intensely for 2 hours a day, and they still return to Earth extremely weakened. The decrease in bone mass can also be slowed by strength training. So far, it's not possible to rid astronauts of cardiac and vascular problems. A lot of this could be fixed by creating artificial gravity on spaceships, but they are usually too small to accommodate a centrifuge. But what if we build a spaceship that would rotate and create an artificial gravity, like those shown in sci-fi movies? The reality is, no space agency is betting on such a development. So far, it's completely out of our reach conceptually, technically, and financially. Meanwhile, there's cosmic radiation, equally destructive to humans. Earth's atmosphere and magnetosphere save us from ultraviolet radiation, X-rays, and gamma rays. This protection has been compared to the equivalent of a concrete wall 30 meters, 100 feet, thick, or an 80 centimeter, 31.5-inch, shield of lead. Scientists have already suggested a very simple solution in the event of space storms. You would just need to hide in the center of a ship or structure behind this specially built wall. Vests with an electrically charged coating that repels radiation are also being tested. But so far, we don't know the extent to which it will be possible to neutralize deadly radiation during long flights. All this makes some scientists doubt the need for human missions to the Moon and Mars. Astrophysicist Sylvia Ekstrom of the University of Geneva completely associates the Martian future with robots. The surface of Mars is covered with regolith, in which scientists have found perchlorates or chemical compounds harmful to living organisms. Humans would suffer from Mars' weak mean surface pressure, 0.6% of Earth's, and much more. Modern space probes already perform many dangerous tasks, and are much cheaper to send into space than humans. This means that the estimated cost of one mission with humans on board would be equivalent to the cost of roughly 40 robotic missions such as Perseverance. Moreover, probes could be sterilized on departure from Earth. Such precautions would protect the places we visit in the solar system from contamination. And yet NASA is confident that humans are more efficient in space than robots. They would be much better at exploring the planet and assessing the situation. The Space Administration has no doubt that manned missions to the Moon will continue and people will be sent to Mars. Do you think NASA will execute its plans anytime soon? Let us know with a comment and leave a like if you enjoyed the video. And to stay updated on anything incredible happening in space, subscribe to our channel. Thanks for watching Dark Core.